Okay. Hey everyone, this is Trent Peterson from AWS Device Farm. Thank you all for joining this morning. Um, Today we're going to go over Device Farm and how to test your mobile applications with this service in the AWS cloud. So let's start with covering the problem that AWS Device Farm addresses. So in today's ecosystem, when you're developing a mobile application, it's not as simple as just developing for something like, say, Android, or developing for Fire OS, or developing for the web. Not only do you have to consider the platform that you're developing for, but you also have to consider all of the myriad devices that are out there. So tablets, phones, televisions, different form factors, different operating system versions, different firmware versions, different modifications from various carriers. There's a very, very large matrix, and it's growing every day. And this is great from a consumer standpoint because there's a lot of choice, there's a lot of choice in the market, and it drives innovation. But from a development perspective, the complexity is very, very large. And so it's very typical, and you're probably very familiar with the process of testing today typically involves piles of devices in cabinets and drawers. Developers might grab a device from a cabinet, plug it into their machine, do some debugging on it. It's a very ad hoc. What we found is it's very ad hoc, and what we've heard from customers is that that testing is very complex, and keeping up with the devices, keeping them maintained, is definitely a burden. And I imagine that you're very familiar with this, but the consumer is very fickle. So you're releasing applications, you're pushing them out to the market. App quality is an increasingly popular, increasingly important thing to look at when you're releasing an application. And so this manifests itself in the app market where simply crashing on a device or having a problem is very likely to send a customer looking elsewhere and looking to a competitive product. So we see quality as an increasingly important competitive advantage. To help customers on in this extremely complex ecosystem, we use Device Farm, which enables automated native hybrid and web application testing on real Android and iOS devices in the cloud. And so what to expect from today's webinar. First of all, we will go through the features and pricing overview of the product. We'll cover the high-level functionality, what exactly Device Farm is, how it can help you, and how it can help you improve the quality of your applications in an affordable way. We'll go through a demo. I'd like to spend most of the time in the demo. I think that that will be the best way of showing you how easy it is to run tests, and also walk you through how to interpret a report coming out of Device Farm. We'll talk a little bit about continuous integration, and I'll show you what it looks like. We have a Jenkins plugin, and we'll go over that as well as other integrations that are offered. And then finally, we'll follow up with Q&A. So what is AWS Device Farm? AWS Device Farm enables you to test your Android and iOS applications. This includes native applications, so fully native, hybrid, think applications developed in frameworks like PhoneGap, Xamarin, and so on, as well as web applications, so applications that run fully in the browser like Chrome and Safari. AWS Device Farm has scalability in mind. So when you schedule your tests and when you're running your tests, you have hundreds of unique devices that you can choose from. And when we say unique, we're referring to things like the Samsung Galaxy S6 on T-Mobile running a specific flavor of Android, and an Apple iPhone 6s running a particular flavor of iOS. And then behind each of these unique devices that you have access to, there are actually many real instances of that device in order to scale. So you have hundreds of devices you can choose from, and then behind each of those hundreds of devices, there are many more devices to make sure that when you want to test your application on a given device, that it's available in a timely manner. This also enables you to deal with actual device failure. So if as you can imagine, we're dealing with, these are real physical devices. These are not emulators or simulators. These are actual phones and tablets. And when you're dealing with the scale that we're dealing with, we do have phones that die and freeze up and so on. And so we want to make sure that we fail over to a functional device. And one more comment on the actual devices. They're non-rooted, they're non-jailbroken. These are the exact same devices that an end consumer would be using. So the same device that if you were to order the device off of Amazon, if you were to go into a local store and buy the device, this is the device that we have in the fleet. So let's talk a little bit about security. So on the security side, we offer full hardware and software isolation. On the hardware side, the devices themselves are shielded from one another, so they cannot actually see each other over a wireless connection. They also cannot take a picture or take a video of the devices around them. They're completely isolated on the hardware side. And then this also pertains to the software side. So when a device is running your tests and a host machine is executing your tests against that device, that host machine and that device have no way of communicating with another device host, another machine that's running your tests. And that includes both the software level and the network level. So there's no way for crosstalk to occur between tests on multiple devices. And in addition to this addressing the security concern, this also benefits you from a stability concern because it means that every time you run a test, you can be sure that you're running on a clean environment that is not going to face interference from devices or tests running around it. Device Farm also offers flexibility. And when we talk about flexibility, there are many test frameworks that are available for testing. So on the Android side, things like instrumentation, which includes JUnit, Robotium, Espresso, UI Automator, and so on. And then on the iOS side, so things like UI Automation, XC Test, and so on. And then some cross-platform frameworks like Calabash and Appium. So there are many frameworks that are out there. And we attempt to address this with Device Farm by enabling all of those frameworks, all of the popular frameworks. We listen to customer feedback, and we're constantly adding additional frameworks and adding additional functionality to make sure that the framework that is right for you, that is right for the types of tests that you would like to run, is supported. And oftentimes we see customers running multiple frameworks within the same company. So the QA team may use one framework, the development team may use another framework, but we want to make sure that there's a way that the entire organization can use the same entry point into Device Farm and also receive results in a consistent manner, and the report is consistent no matter if you're testing Android or iOS, and no matter if you're running Appium or Calabash or JUnit, it doesn't matter. The reports are going to be consistent. So on the report side, once you've run your tests, and we'll see this in the demonstration in a couple minutes, you get results, high-level results. So how many tests passed, how many tests failed, how many tests had a warning, and so on. And then we allow you to go deeper, and we show you here are the unique problems that occurred. So we actually isolate and bubble up the issues that we see occurring more often than others within your tests. And then we're also capturing screenshots. So if you're running your own tests, you can actually trigger when your screenshots are taken, and we'll take care of pulling those back into your report. We're also gathering logs, both off of the device, the test framework that you're using, and the device or the machine that hosts the device. So we're taking all of those logs and putting them onto a consistent timeline. And then finally, we're gathering performance data, so things like CPU, memory usage, thread counts, and so on. In order to use Device Farm, you can use it through the console, which we'll use in the demonstration today. We also offer a number of integrations, including Jenkins, Android Studio, the AWS SDKs, and the AWS CLI. And we'll actually go over this in a little bit more detail later on in the webinar. And finally, and we'll talk about this a little bit more, pricing is pay for what you use. So there's no minimum buy-in. It's totally based on device minutes. It's whatever you choose to use is what you pay for. It's very simple. There's a flat per device minute rate, and I'll talk to those in a few minutes. So going down the pricing front, so everything is priced at 17 cents US dollars per device minute. So if you run a test that takes 5 minutes, you run it on 5 devices, that would be 25 device minutes, so 25 times 17 cents. We also offer the concept of an unmetered device slot. And an unmetered device slot is essentially you would choose either Android or iOS, and that's where that's as specific as you have to be. You don't need to choose, I want an iPhone 6S or something like that. You just say, I want an iOS device or I want an Android device, and you can choose as many as you want for $250 each. And then when you schedule a run, we essentially cap concurrency at that number. So if you were to purchase 5 unmetered Android devices and schedule a test on 10 Android devices, we would run them 5 at a time until your tests were complete. And that would be flat rate $250. Whereas you could also select, if you were to use the standard meter pricing, if you selected 10 devices, you would be charged at 17 cents per device minute on each of those devices. So it gives you flexibility in deciding if you want to pay for what you use or if you want to choose a flat rate model. This can be a way for you to choose if you want that predictable pricing or if you want to have a more flexible pricing plan. And finally, you can start today, and after the demonstration, I would encourage you to give Device Farm a shot. You start with a one-time free trial of 250 device minutes. So in order to get started, all you have to do is upload your application. And we'll go through this in the demo, but that application does not have to be instrumented in any way. This is simply the binary build of your Android app, so an APK, a binary build of your iOS application, so an IPA, or it's a web application, in which case you don't have to upload an app at all. You simply upload your tests. Then you select your test framework that you would like to use. And like I mentioned before, we support a number of popular automation frameworks. We also provide a couple frameworks that you can use that require no testing or no test automation on your part, or no scripting on your part. We have a built-in Explorer that will crawl your application, and we also have a built-in Fuzz test that will hit your application with random input. You can think of this like a monkey testing or fuzz testing framework, and it requires no scripting on your part, like I said, or you can upload your own scripts. Once you've done that, you upload those, as I mentioned before, you upload your application, you upload your tests, you set your configurations. Then in AWS data centers, we host actual physical phones and tablets, like I mentioned before. We're going to run your tests, pull back the results, and then provide you with a report. And with that, let's go ahead and jump into the demonstration so you can see Device Farm in action. So once you've logged into the AWS console, under the mobile services category, you'll see Device Farm. We'll jump into Device Farm. Now, the first concept to understand in Device Farm is the idea of a project. In a project, you can think of this as your workspace. This is where you're going to group your test results, group your test runs, and your projects are not platform specific. So you can create projects for a title that you build and include both the iOS and Android versions of that product, or you can split them out and have the Android have its own project, iOS have its own project. and so on. It's completely up to you how you use the concept of a project. So for today's demonstration, we're going to go ahead and create a new project. And now I've jumped into that project. So the first step, when we create a new project, when we go into it for the first time, it's going to prompt us to create a new run. A run is the second concept that I would like to describe for Device Farm. A run is going to consist of a specific build of your application, a specific set of tests and their configurations, a specific set of devices, and a specific set of device configurations. And now we'll walk through what that process looks like so you can understand what each of those components consists of. It's actually very fast to go ahead and get started. So the first step is choosing our application. So for today's demo, I have an Android application here. And as I mentioned, the build that we're uploading is a simple APK. It's a binary. Add any code. I don't have to add any SDK or any instrumentation to the build whatsoever. This is the exact same build that I would distribute to my own beta testers, potentially the same exact build that I would actually submit to the market for publication. So again, there's no modification to our source code. This is the same build that we would be using to test locally. Once this application is uploaded, there will be a brief processing that will happen on the Device Farm side, where it verifies that this is a valid application and displays to us some information. And we can see that some information out. One of the important things here is minimum SDK. It's going to use this later on in the process when we're selecting devices to scope the devices that are supported by our application. We'll go ahead and leave the run name as the default, which is the application name that we've uploaded. Step 2 is to configure the test. So as I mentioned before, we support a number of popular automation frameworks, and a couple of them are also frameworks that require no testing, or no development or scripting by you. So the built-in Explorer, the built-in Fuzz. And there's, as you can see, there's a username and password field for the built-in Explorer. This allows you to supply the Explorer with credentials, in which case, if the Explorer encounters a login form, it will use your credentials to attempt to go through the login and continue on exploring your application. We also offer a fuzz test, which will hit your application with random events, and you can help specify, or you can specify which, how many events are going to hit the application, as well as the time to delay between those events. In addition to those built-in tests, we also offer support for a number of popular automation frameworks. For today's demonstration, I'm going to use instrumentation. So this includes JUnit, Robotium, and Espresso. So we'll go ahead and upload our test, our instrumentation tests. Similar to uploading our application, we're going to do some validation on the server side and make sure that your tests conform to what's expected for Device Farm. But also, like your application, we don't require you to add special code to your tests or anything of that nature. It's very important that this is as easy and seamless as possible for you to run tests. So this is the same application. These are the same tests that you would use to run locally in your environment. So you don't have to do any special modifications to the app or the tests in order to run them on Device Farm. Once we've uploaded our tests and configured our tests, we're ready to select the devices. So by default, we're going to have selected for us the curated pool called top devices. And this is a set of devices that we maintain on the Device Farm side of popular devices that we see in the market. Devices pool is largely focused on the North American market. A little bit later, will evolve created pool. We also have the capability to specify that pool is and has 100 devices to choose from. Now, I'll select the devices that we want to test on, and you'll see here that we have multiple operating systems explicit. We also have the concept of rules. What this allows us to do is create a pool that will adapt as the fleet for Device Farm grows. So if a new Samsung device comes out and we want to make sure that we're testing on it, we can go ahead and we can create a rule-based device pool, and every time that AWS adds a Samsung device to the fleet, it will automatically get pulled into your device pool. This allows you to create dynamic pools that grow as the Device Farm fleet increases. So there are two ways, like I said, of creating a device pool. One is explicitly setting the devices you would like to test on, and the other one is creating it using rules. For today's demonstration, I'm going to go ahead and just use the top devices curated pool. Once we've selected devices, we can specify the device state. This is an optional step, but it allows us to do some pretty powerful things. So the first thing that we can do is we can add extra data. Extra data means supplying us with an archive that we will unzip onto external data on Android or into the application sandbox on iOS. So if your application or your tests need to make use of media files or a special configuration file or a database or something of that nature, this allows you to place those onto the device. The next thing you can do is install other applications. So if your application has dependencies, for instance, on an application like Facebook or so on, this allows you to upload those applications to Device Farm and specify the order in which they should be installed. This will occur before the application that we uploaded in step one, the actual application under test, which means that not only can you test integrations or dependencies that your app may have, it also allows you to test upgrade flows from a previous build of your application. So you could upload a previous build in this step and the new build in step one that we did a little bit earlier, and actually test that upgrade flow. Next up, we can define to enabled when our first time after installation testing Snow application. Next up, we can specify the device's location. This specifying the latitude and longitude that the device will appear to be in. Useful for testing things like geofencing and so on. So again, even though those devices are in statically hosted in AWS data centers, you can place those devices virtually anywhere in the world. And finally, we have the device's locale. This allows you to set the language and dialect of the device, which is useful for testing things like localization of your application. We just take a quick look. Our run looks okay. I mentioned before that we have a couple different ways of billing. So if you had purchased unmetered devices, you would actually be able to choose on this screen if you want to use those unmetered device slots or if you want to use the metered 17 cents per minute. For today's demo, I'm going to go ahead and use that metered plan. So I unchecked the box to use my unmetered devices. Once I've scheduled the run, you'll be brought to a list of runs. And since this is a new project, this is the first run. and we can see that it's in the scheduling state. And then shortly after it's in the scheduling state, we oftentimes see it get picked up, and now it's actually executing. If we click on the run, we're brought to a more detailed report that can show us which devices are actually executing tests and which devices are not. So Device Farm uses an opportunistic algorithm, so the curated pool. We can see now that 3 of those devices were immediately available and have immediately started running tests, and we have a couple others that are waiting until the device becomes available. And typical wait times, it's usually you'll see tests start to run in seconds, if not, or in minutes, if not seconds, and we can see that more tests are as devices become available, more tests are running. And we're constantly monitoring the fleet, monitoring it for utilization, and increasing our capacity to make sure that when you run your tests, those devices are available as soon as possible so that you can get the results you need. Waiting hours, for instance, that's definitely we would want. And as you can see now, all of our tests are running. So as those tests complete, a report will start to be generated. And I described the report a little bit earlier, that it consists of those high-level results, screenshots, and performance data. So while these tests are running, and the tests that I've uploaded, again, are instrumentation tests, they take about 15 minutes to run. Rather than wait the 15 minutes for those to run, I'm going to go ahead and jump over to a previous run that I have of the same test, so we can walk through what a completed report is going to look like. So this is the run list from another project. And as you saw before, we created a new project. We had a single run. This is a project with many runs, as you can see. And you can also see that it has a mixture of iOS runs and Android runs within the same project. Let's go ahead and jump into one of these runs, one of these Android runs. So the first thing that we can see are those high-level results. So we can see that 271 tests have passed, and we can see that 9 tests have failed. In all likelihood, the first thing that we're interested in seeing is which of those tests failed and why did they fail. So the first thing that shows up in the report as we scroll down are unique failures. So what we do is that Device Farm will group your fails. In this case, we had 9 failures. However, only 7 of them were unique. One of those failed 3 times. And so we pull that out in hopes that it allows you to fix it in one place. And if you fix it in one place, the idea is that it fixes it likely in all of those places. It also allows you to jump straight to the problem. So we can click on one of those errors or one of those failures, and we go straight to the device on which it occurred, in this case the Samsung Galaxy Tab 4, the suite in which it occurred, and I'll talk a little bit more about this in a second, and a specific test, which in this case was test to see if the NFC was on. As we scroll down, we can see that we have full logs, not just from the device, but also from the harness, which is the machine that hosts the device, as well as the test itself, the test framework. The log is fully searchable and filterable and sortable here on this view. You can also download this file in JSON format for local analysis. In addition to the logs, we also provide screenshots. In this case, we have a single screenshot for this particular test. And again, it's up to the script to decide when the screenshots are captured. And in this case, the script is capturing a single screenshot, which is displayed here. We also offer performance data like CPU, memory usage, and thread counts. And again, these are all scoped to the particular tests that we're looking at, in this case, that NFC on test that failed. And finally, we have files. And files allow us to download the actual raw log cat from the device. And then other files will depend on the type of framework you're running. And in this case, we were testing Android using JUnit or instrumentation. So we can actually download the instrumentation output file. And we'll cover this in a little bit, but I just want to point out that everything that you see right now in the report is available through our API. The console here is actually, so everything you see here is available programmatically by your own integrations. So I'm going to go ahead and jump back over to that summary view that we looked at a couple seconds ago. And as we scroll down, right below the unique problems, we can see a list of all of the devices that were tested on. 4 of those devices had failures, and we can see that 1 of them was a pass. Now, each of those devices, we can click on it, and we're brought to a list of, typically you organize suites, and then within each suite, you can have 1 or more tests. Every single suite, or every single run on Device Farm will have a setup suite, which is a suite that Device Farm generates. This is your actual installation of your application. And we can jump into that and see what exactly occurred during installation. This can actually be helpful if your application doesn't meet certain requirements for the platform or for the device that you selected. Is the teardown suite, which is when we uninstall the application. Now, we're looking at a device, and if we click on screenshots, we are actually shown screenshots for every single suite within the device that we're looking at. So screenshots are scoped to the device at this point. The same goes for performance. So we can look at the performance tab, and we can see their performance for every single suite and every single test that was run on the device. And finally, we can look at the Files tab, which will contain all of the individual file artifacts that are available for every single suite and every single test that was run on it. So hopping right back over here to that details view, if we go 1 level deeper, we can look at a particular suite, and you'll see that the interaction here, the report looks largely the same. We have the same tabs, screenshots, performance, and files down below. All that's changing as we're drilling deeper is that the scope of the report we're looking at is shrinking down, zeroing in on the level of granularity that we're at. So again, we can look at screenshots, but now we're just looking at the individual tests that were with. This is a specific test within a specific suite on a specific device within a specific run. And again, that run is a specific build of your application, configuration data, and a specific set of devices. So we'll hop back over and see how our run is doing. And that's going to take 15 minutes to complete. So while we're waiting for that, let's go ahead and actually upload and schedule an iOS application. So again, running your tests or running an application through Device Farm, the iOS is similar to Android. It requires no special instrumentation, no special sourcing or source code development at all in order to run your application. This is the same IPA that you would submit to the market. And now for this demo, I have XC tests actually written. I'm actually using Swift, Swift-based tests for this demonstration. But again, similar to Android, we can see that there's a set of popular frameworks like UI automation, XC tests that are specific to iOS, as well as cross-platform frameworks like Calabash and a couple flavors of Appium. And now that we've uploaded our tests, we're ready to select devices. Just like with Android, we can see a set of devices down below. These ones are obviously Apple since we've selected Apple devices. Again, this is the curated pool. And just like with Android, you can also create your own pool using Apple devices. So as you can see, we have a large number of Apple devices available for testing. And then once we've selected our devices, once again, we can add extra data, install dependencies in previous versions of our application, override the latitude, longitude, and specify the device's locale. And once we've scheduled it, once again, it goes into the scheduling status, and then as those devices become available, they will start executing tests just like we've seen. So as you can see, we're running both Android and iOS tests at the same time in parallel. So now that we've looked at a demonstration of how you go about uploading your application and scheduling tests and running tests on Device Farm, as well as interpreting those reports, I'd like to talk a little bit about continuous integration, as well as integrations in general. So we publish a couple official plugins, one for Jenkins, a continuous integrations environment, as well as Gradle. And the Gradle plugin actually is interesting because it also allows you to run tests straight out of Android Studio, so straight from the IDE. While you're building your Android applications, you can kick off tests on Device Farm. In addition to those official plugins, we also provide some ways that you can integrate Device Farm into your development process in ways that Jenkins and Gradle doesn't cover. So we're included in the AWS CLI, and we're also included in the AWS SDKs. And AWS SDKs, if you're not familiar with them, include languages like Python, Ruby, .NET, Java, JavaScript, and Go, and so on. So many languages are available. And the cool thing about this is that it allows you to integrate Device Farm into, say, your issue tracking system or into your documentation system. You can automatically pull down portions of reports or potentially schedule entire Device Farm runs straight from your own tools. So let's go ahead and look at what the Jenkins integration looks like. So we're looking now at the Jenkins dashboard. And in Jenkins, we have the concept of a dashboard, so we can actually see here that we have a project called My Android Application. And with the Device Farm plugin, we can actually see how many tests have passed or failed or errored or skipped or stopped, and all of the various statuses that a Device Farm run can include. We can see them here. And if we jump into that project, we can also see trends. So how many tests from build to build are passing, failing, and so on. Down below, we can also see the build number. And for each build number, we can see its overall results. And we actually see a link to the full report. This allows us to easily just click this link and jump straight into the console to view the report on Device Farm. Now, as I mentioned before, in addition to viewing the reports on Device Farm, it's also possible for you to pull those down programmatically. So if you want to do your own local analysis, that's entirely up to you, and you can use the API and pull them down. And the Jenkins plugin itself actually allows you, in its configuration, to specify that you want it to automatically pull down screenshots and log data. So you can skip that step and go straight to the analysis portion of your workflow. And finally, if we jump into the actual build, we can see here that we have access to the build artifacts. So this is the application and the test that was used. We can also see the individual pass, fail, and other counters available for that run. And this plugin is open source. You can also install it straight from the Jenkins repository. So if you go into, if you're configuring Jenkins, you don't even have to pull down the source code and compile it yourself. You can just pull it down straight from within Jenkins itself. And that documentation is all online. And the end of the presentation, which will be made available to you, includes a link to learn more about that, as well as the Gradle integration. Here's a screenshot of a Jenkins integration that has multiple projects with multiple device farm results, different results depending on the project. So as you can see, we have various applications and builds all in the same Jenkins dashboard. And then here is a screen capture of a particular project that has numerous builds within it. And we can see that there's a trend chart that actually follows along with those builds. We have about 15 minutes left, and I would like to open it up for Q&A. I'd also like to thank you for joining this webinar. I really appreciate you taking the time today to learn more about Device Farm. I hope that it was informative, and I hope that you can see value in testing your applications with AWS Device Farm. I also have a couple links here. If you go to the service link, if you go to Device Farm, you can actually find from there information about pricing, information about the service itself, as well as a way to get into the console and check it out for yourself. And like just for signing up, you get a one-time free trial of 250 minutes, so you can kick the tires and try it out for yourself. And if you have any questions, we have a forum where you can ask questions. The community or representatives from AWS will chime in and help you out. And we also publish samples. So we understand that getting started with automation, not just with Device Farm, but just with automated testing itself, can be a somewhat daunting task. So we publish a number of samples, both for iOS and for Android. That includes a sample application, as well as sample automation written in a number of the frameworks that we support. So if whether you're trying to get started with Espresso, or Appium, we publish sample tests sorted by the type of interaction you're trying to automate within your app, following automation best practices, which is an interesting topic that could probably have its own webinar about how to write automation that is robust enough to run against many different devices, some of dubious quality. And so with that, I would like to turn it over for questions. And hopefully we'll spend the next few minutes here answering those questions. I apologize for the delay here. I'm getting access to the questions now. So let's go through the questions. So is there any flexibility for Windows Phone? So today, Device Farm is focused on Android and iOS. However, the Device Farm is designed to be platform agnostic. So when we launched, we supported Android only, Android and Fire OS. Shortly thereafter, we added iOS support. And within the last month, we added support for web testing. So this allows you to test web applications in Chrome on Android and Safari on iOS. So we're certainly open to the possibility of supporting additional frameworks. I don't have any states for support, but like most things within AWS, it's driven entirely by customer feedback. So if there's a desire to test Windows Phone, we'd be interested in talking to you, learning more about the applications that you're developing, the tools that you're using to test, and what your timelines look like. So please do be in touch with those requirements so that we can learn more. There's a question about whether or not you can remotely interact with the devices in a manual fashion. So today, caters to automated testing and does not cater to the use case of remote access to the device in a manual fashion. However, again, similar to my last answer, we are completely open and planning on allowing additional ways of interacting with the devices, additional ways of utilizing the device fleet in ways that help you develop better applications or develop applications and perform your day-to-day for testing applications and so on. So again, if you have a specific use case like remote access to devices, we'd love to talk to you and learn a little bit more about what kind of testing that you're looking for and how we might be able to help in the future. There's a question for whether or not you need to add all UDIDs of the iOS devices in the fleet in order to test on device farm. So the answer is no. We actually replace the provisioning profile of the application and re-sign it. So we take care of it. The iOS application that you submit to us, you can sign it however you want. And like I said, we're going to take care of stripping that provisioning file out, replacing it with a wildcard cert, and re-signing it. So no. And of course, one caveat there is that when we re-sign the iOS application, this may break certain functionality like push notifications that actually depend on the application signature. You can learn more on the FAQ, which is available through that public Device Farm website that I mentioned towards the end of the presentation. And if you have any additional questions, again, please feel free to reach out. There's a question about whether or not you can configure test cases and upload custom data to be tested against that test case. So we do not provide out of the box a way for you to supply individual data to specific test cases. However, you can use certain, we have customers that use various strategies when addressing this use case. If you need particular data for your test cases in order to perform, you have a few options. One, when you're configuring the run, you do have the option of passing certain things in like filters, so you can specify which tests within your test package you actually want to run. This is done when you're scheduling the test. You also have the option of providing extra data, which I mentioned during the demo is a way for you to populate data onto the memory of the device under test. So you could actually use this functionality to upload configuration files, test data, whatever you want. However, it's going to be the same across all devices you've selected for the run. Finally, if you want to do this in a dynamic way, we've actually seen customers that have tests that actually call out to some remote server or some remote resource and pulls down the configuration data on the fly for the test to consume on a particular device. There's a question about whether or not Device Farm is just for static apps or whether it can support dynamic apps that contain video recording or data in forms. So applications, like I showed in the demo, the tests that we're running, since those tests are written by you, they can actually exercise the business logic that you're interested in testing. So it enables you to inject text into forms, press the buttons that you want to press, open up a video stream, play it. The devices themselves have internet connections through a dedicated Wi-Fi per device. So you can definitely pull down information, stream video, stream audio. You have permissions within your application, and you can actually use the camera or video. You can actually totally do that. You can record video, you can take pictures. However, since the devices are stored in a completely isolated fashion, the photos and the videos are not going to be very interesting. They're going to be blurred, they're going to be dark. You're not going to be able to make out much, but you can definitely test the functionality of whether or not you can perform those actions on the device. There's another question around iOS applications and whether or not any additional configuration is necessary. And similar to the question about UDIDs, both for Android and iOS, no additional configuration is necessary for the apps in order to test it. There's a question about how easy is it to configure the Jenkins plugin. There's a previous webinar that we did that you can find on YouTube from November where I walk through both installing and setting it up. We also offer documentation on the GitHub page for the plugin, as well as on the actual docs, AWS docs page. I'd be a little bit biased, but I would like to say it's very easy. You can simply go to your Managing Jenkins page, go to Plugins, go to Available. You simply filter the list down by AWS Device Farm. It's going to show up there in the list. You hit Go. And the most complicated thing is it's going to require you to enter an IAM user, where you need to go to the AWS console, create a new user. This is very convenient because you can actually create a user that's only for your Jenkins installation. You simply take the secret key and the key and put them into the Jenkins configuration, and you're just about there. Then it's as simple as entering in your project name, the device list that you want to run, and entering the location of where your actual application is going to appear, so that Jenkins actually knows where to look for your application to test. Again, I'd encourage you to read the documentation, look at that webinar, and if you still have questions, reach out through the forums, and we'll be happy to help. There's a question about network throttling and network virtualization on Device Farm. So as I mentioned before, the devices themselves have access to the internet through a Wi-Fi connection. Today, that Wi-Fi connection is not configurable by you, so there is no throttling or virtualization that's available. However, it's definitely something that we've heard from customers, and it's something that we're open to pursuing. And if you have specific needs or requirements here, we'd be interested in talking to you to learn a little bit more about what it is that you're looking for when it pertains to network virtualization. There's a question about which countries our servers are currently located. Currently, AWS Device Farm exists in US West 2 as its sole region. However, it's available globally, so you can definitely use the service and use those devices regardless of where you are. The devices are all in the same region as the rest of the service. And we do plan on expanding the device coverage, and we're actually in the process of it. If you look at the available devices, it doesn't include some Chinese and Indian devices today. We're looking at other markets. We're also looking at expanding our coverage within the markets we already support, which is primarily North America. And then also, like I said, a little bit of China and India. We're constantly, and also if there are devices that are missing or devices that you would like to see tested, please get in contact with us and let us know. We listen to customer feedback, and I can't guarantee you that the device that you're looking for is going to be added to the fleet, but it's definitely great to hear directly from you what it is that you would like to see available for testing. There's a question about Appium and whether or not the code needs to be written in JUnit or test in G. The answer is yes. Those are the two flavors of Appium we support today, JUnit and test in G, both for Android, iOS, and web. And this is because of the way that we support Appium. So rather than giving you an endpoint and you run the Appium server locally on your machine and then connect to an endpoint that is our device, when you actually upload all of your tests to us. We take care of spinning up the server and talking to the device on each device that you've specified. The nice thing about this is it eliminates any latency between your server and the device. It also means that we can generate an aggregate report across all the devices you've selected. So the burden is not on you to take care of pulling down results and aggregating them. It also means that the burden of actual parallelization is not something that you have to worry about. We'll take care of fanning out your Appium tests across all the devices you've selected. The downside to this is that you're limited to the flavor that we support, which again is JUnit and test in G today. However, we are looking at other flavors of Appium to support in the near future. And again, a lot of that is driven by customer feedback. So if there's a specific flavor of Appium, if you're looking at, for instance, Appium Python or Appium Ruby or so on, we would love to hear from you. Of Appium. There's a question about how to test a website or web application on Device Farm. So we recently released support for testing web applications in Chrome on Android, Safari on iOS, and you do so using Appium in the flavors that I mentioned before, which is JUnit and test in G. If there are other frameworks, like I mentioned before, both either from Appium or some other web framework that you're using, we would love to hear from you so that we can be sure to cover additional use cases. There's a question about the $250 unmetered use per device per month, whether that's for the device per month or any number of devices per month. So it's actually for any number of devices per month. You're basically purchasing a slot of concurrency. So if you select 5 Android devices, 5 unmetered, that's going to be 5 times $250 or $1,250 US per month. You can select as many devices as you want per run. You can schedule as many runs as you want. You're simply going to be limited in concurrency or parallelization by the number of devices you purchase. So if you purchase 5 in my example, and you schedule on 100 tests or 100 devices, it's actually going to run on 5 over and over and over again, 5, 5, 5, 5, 5, until it actually runs on all 100 devices. You can schedule additional runs, subsequent runs on different devices. It doesn't matter. You're simply limiting yourself to those 5 devices at a time that you purchased in exchange for the convenience of having a flat rate. The other option would be to run on all 100 devices at the same time and pay 17 cents per device minute. So we're about done here. I think we have time for maybe one more quick question, and then we'll let you all get back to your day. There's a question: are the devices being used real or emulated? And the answer is that all of these devices are 100% real. These are the exact same physical hardware that you would go into a store or go to Amazon and purchase. We do not use simulators. We do not use emulators. These are all real, unrooted, non-jailbroken devices hosted in AWS device data centers. So with that, I would like to thank you all again for taking the time today. I really appreciate you taking an hour out of your busy schedule to learn a little bit about Device Farm. Again, please give it a try, as well as reach out to us through the forums, contact us via email. If you have any questions whatsoever, we're here to help. Thanks again and have a nice day.